Okay, so this related rates problem tells us that a bubble is inflated at a rate of 2 centimeters cubed per second. Okay, so that's its volume changing. The question is, how fast is its surface area changing when its radius is 12 centimeters? Okay, so what do I know? Okay, first of all, here's my bubble. There's my radius. So now I know, okay, we're told the rate at which the volume is changing, so dV by dt, it's being inflated. So we're adding 2 centimeters cubed per second to that bubble, okay? Which means I probably need to know something about the volume of this thing. And I know that the volume of a sphere, the bubble will be roughly spherical, well, roughly, very close to spherical, okay? 4/3 pi r cubed, okay? Now, I'm interested, what I want, okay, is let's say dA by dt, the surface area. dA by dt, that's what I'm interested in. I know that this is going to happen at the specific moment when the radius is 12 centimeters. I also know that my surface area, and actually normally I would use like SA there, but I'm just going to use A, is going to be 4 pi r squared. Okay? So this is an interesting question here, because normally what I would do here is I would try to relate V to A. So here are my equations for V and A. Now I can do this, but it's going to be rather awkward to set that up here. I think a more straightforward thing to do here is, I know that both of these have got R in them. Okay? I know that when I'm inflating this thing, putting air into that bubble, okay, that the radius is going to change, and that changing radius is going to have a direct impact on the surface area. So maybe what I'll do is that. Okay, although this question isn't specifically asking for dr by dt, I need to get that. Okay, I want to figure out what this is, and then I'm going to use this to figure out what that is going to be. So there's just some steps here that I got to get through. So here we go. Let's zoom in a little bit and let's jump into this. Okay, so I'm going to jump in to start off with, we're going to look at volume. So volume is 4/3 pi r cubed. I'll take the derivative of that right away. So dV by dt is going to equal 4/3 pi 3r squared. And then because I'm taking the derivative with respect to time, I got to do this implicitly, dr by dt. I know that volume, dV by dt, the change in volume, is going to be positive 2, because it's increasing, I'm inflating it. The 3's here will cancel, so 4 pi. And the specific moment that I'm looking at here is when the radius is 12. Now that's going to be true for this whole scenario. So right now I'm going to just plug in that 12 squared, and I'm looking for dr by dt. So I'm going to divide this stuff through, so this will be 2 over 4 pi, 12 squared is 144. That'll be dr by dt. And what do I got here? I can do a little bit of canceling. So this will end up being 1 over, looks like 288 pi. And this is going to be, based on the units that I've got here, centimeters per second. Okay, dr by dt. So there's my change in radius. That's not my final answer, but I needed that to move on to my final answer. So now let's take a quick look. Okay, area. The area of a sphere is 4 pi r squared. So now I'll take the derivative of this with respect to time. So this will be 4 pi, and again, this has got to happen implicitly with respect to time. I am looking for dA by dt. That's the thing I don't know. So now I'm going to plug in everything I do know. Well, 4 times 2 that's going to be 8 pi. That radius there is going to be equivalent to 12 at this particular moment in time. And I know now that dr by dt is 1 over 288 pi. Okay, well, I'm going to simplify this. The pi's are going to cancel there. And then I'm going to get, what is it, 8 times 12 divided by 288. Oh, would you look at that? 1/3. So this is changing. Now based on the units that I've got here, okay, remember that this was going to be centimeters per second. The radius there is centimeters, so this is going to be centimeters squared per second, which is exactly what I would expect it to be with a change in area. So there we go. 1/3, which is, if you need this is in a decimal form, although that's probably clear enough, it's a nice fraction there. That's going to be 0.3 centimeters squared per second. There you go.